So I'm really interested in your work, and I want to know how you first thought to even look for historical entanglements. How did you even find that kind of data?
Well, it was actually kind of by accident. So we already knew about the microplastics,
Yeah.
and we'd been counting them and categorizing them since a paper that came out in 2004 by Richard Thompson, who's at Plymouth University.
So that's inside the continuous
That's
plankton
in
recorder.
the actual silk samples, yes.
Yeah. So
And
with the phytoplankton.
with
next
the
to
plankton, with the zooplankton, everything.
Wow.
And sometimes we even see them, wrapped around the zooplankton or inside them.
Wow.
But the entanglements was by chance, really. We have a team of guys in the workshop who work really hard cleaning up the plankton recorders when they get bashed about and fixing them up. And they were noticing that more and more we were getting entanglements around the propeller and around the actual body of the plankton recorder, like big pieces of plastic. And I said, well, is there any way that we've been recording that? And they said, yeah, I mean, the crew that bring up these plankton recorders for us, so it's all a volunteer scheme.
Yeah.
There's a comments section, and they'll often record the sea state and whether the plankton recorder is towing appropriately, but they'll also report any entanglements, so whether we get bits of seaweed, bits of wood, but also bits of plastic. So it's in this comments section. So that's where we created the database, and since 1930s we've had these records of entanglements.
Wow. 1930s.
Yeah, well, that's when the plankton recorder started.
Wow.
But actually the first record we had of an entanglement by a human piece of plastic was in 1957. We had some trawl twine, and then in 1965 we had our first plastic bag. So because it's remained consistent for the last 60 years, we're able to show that increase in large plastic items entangling, and able to map them as well in the North Atlantic. So it is really exciting, and I'm so keen to see how we can link in with satellite work again, because we don't tow in the coastal areas, and we don't necessarily have the coverage that you'd get from satellites. So I'm really intrigued as to how do you actually take a picture and then use that to know if this is plastic or if it's just a piece of wood.
Well, actually it's really interesting, because I think this is a nice example of how data that you think you should throw away ends up becoming really important. So with you, it was wrapped in plastic, it's rubbish. But for me, actually, when a satellite takes an image of the coastal zone of the ocean, most of the time, if you're trying to derive things about the water, you want to throw away things that are reflective. So you want to throw away the data where you're like, oh, there's something over there and it's reflecting.
Right.
But I've gone, that's information. Why is that floating there? What is it reflecting?
Neat. So it's kind of similar.
Yeah,
there's kind of side branches that lead you into these exciting things.
And it was the same sort of thing where I was like, that's weird. What is that over there? It's really bright. It's right near a river mouth. I sort of see it in images quite often now. What does it mean? And I went and I sort of dived into it because I was curious. And suddenly there's a whole thing now where we're trying to publish on how we use satellite data. So, for example, water absorbs really strongly in the shortwave infrared, which is one of the bands that Sentinel-2A and B have.
Okay.
And so anything that's floating on the surface of the water is not going to be reflecting in the shortwave. Is not going to be absorbing in the shortwave infrared. It's going to be reflecting.
Right.
So I leverage a detection algorithm around that very simple thing. I use near-infrared light and shortwave infrared light in the bands that Sentinel-2 have, and I sort of leverage them to say, okay, this is floating on the water. It's definitely not algae. It's not plant material because it's not photosynthesizing. So it has to be something else. And then when we look in areas where we know there's a plastic problem, it's more than likely to be plastic litter.
That's brilliant. Exciting stuff.
Yeah, but it is. I think it's a really nice example of where you should never throw away any of your data. It might always be something interesting.
Yeah, and that's something we've learned at the Plankton Recorder here is we store all of our samples. So we've got this huge biological library.
Oh, wow.
And now with techniques in plastic identification, we've got new techniques looking at the elements of items. So you can go in and go back through the historical record and start to pick out those things. So it's exactly the same with these images. If you store them, you can always go back.
Well, that's right. So the European Space Agency has, and obviously NASA have collected all of the satellite data that goes back to the 70s, not at the kind of resolution that I need, but that data is available and it's stored. And if you want to go and look at a satellite image, you don't need any credentials. It's freely available to the public. You can go on something called EO Browser and go and look at the data yourself. And I really like that because we've got data going so far back, and as the techniques improve and as our understanding improves, we can get all of this data from old information and all of these new results.
Really cool, massively important.
I know, we're such nerds.